Okay, video 6 of my diagnostic questions, all about standard or scientific form. So when you write very big or very small numbers in a certain conventional way to reduce writing all the zeros. So the first one, 31,200. So you've got to think of a number between 1 and 10 with the same digits. So that's got to be 3.12 from the digits 3.12. And that's going to be equal to, or the original number is going to be equal to 3.12 times something that's a 1 with a lot of zeros. Now, what I do is to write the number that's the 1 with lots of zeros directly underneath the original number. So you can see that 31,200 is the same as 3.12 times 10,000, because I've written 10,000 under the 3.12, and you can see that where there's a 1 in 10,000, there was a 3 in the original number. So it's about 3 times as big, plus the extra 0.12. So that equals that, and that's equal to 3.12 times 10 to the power of 4. Easy rule, count the zeros, 1, 2, 3, 4 zeros, and that's in standard form. Next question. 0.0046. Actually, I wish I'd written that a little bit further over. 0.0046, because I like to write my number between 1 and 10, which is going to be 4.6 over here. And 0.0046 is equal to 4.6 times a number that's a 1 with lots of zeros. So again, if I write it underneath here, if I put a 1 there underneath the 4, you can see that the number 0.00 and then with a 4 there instead of a 1 is about 4 times as big as 0.001. Plus you've got the 6 giving you a bit more. So that's equal to 4.6 times 10 to the power of minus 3. Again, easy rule, count the zeros, 1, 2, 3, including the 1 before the decimal point. Now, of course, the classic mistake with this question would be to go to all the way to the end of the number, and instead of writing 0.001 here, filling out the whole space of the number and going all the way to the end in line with the 6 there, so 0.0001. But if you look at how that lines up, hopefully you can appreciate that 0.0046 is 46 times as big as 0.0001 and not 4.6 times as big. So you need a little bit of common sense in just recognizing where to put the 1 in order to make it correct in relation to the other numbers. Okay, the next question says write 1.6 times 10 to the 4 as an ordinary number. So 1.6 times 10 to the power of 4 is 1.6 times a 1 with 4 zeros. And then again, I like to write my numbers in line. 1.6 isn't much more than 1. It's just 1 and a bit. So the answer is still going to have a 1 there, but then it's just going to have 6000 there. And hopefully, by having written that in line, you can see that my final answer, 16,000, is about 1.6 times as big as 10,000. Just writing it in line there helps you to get the number of zeros right. And then question D, so we've got 3.66 times 10 to the power of minus 6. So that's going to be a very small number, 3.66 times a number that's got 6 zeros in it. 1, 2, 3, 4, 5, 6. A 1 on the end and then a decimal there. So it's got 6 zeros, including the 1 before the decimal. So we want a number that's about 3 times as big as 0.000001. So where it's got a 1 there, because it's going to be about 3 times as big, the 3 is going to go there. So it's going to be 0.000003 there, and then the extra 6. So I've just gone off the page there. Yeah, so 0.0000366, and again it's important to line these up just to help you get the zeros and the decimals in the right place. Okay, the last couple of questions involve doing a bit of calculation. So you've got to multiply two standard form numbers, 6.4 times 10 to the 6, multiplied by 3.2 times 10 to the power of 4. Now the trick to this is to do all of the regular numbers first, the 6.4 times the 3.2, and all of the powers of 10 at the end, because the order doesn't matter with multiplication, so you can just change the order around. Now 6.4 times 3.2, let me just get to that. 6.4 times 3.2, 20.48, 20.48, and then 10 to the 6 times 10 to the 4 is 10 to the 10. You just add the powers. So answer 20.48 times 10 to the power of 10, but that's not in standard form. So we just need to make the first bit 10 times smaller and make it 2.048 by moving the decimal. But then because we've done that, we're going to make the next bit 10 times bigger, so it's 10 to the power of 11. So final answer in standard form, 2.048 times 10 to the power of 11. Okay, last question. Calculate 3.2 times 10 to the power of 4 divided by 6.4 times 10 to the power of minus 7. Now, the way to do these is to write them, instead of with a division sign, write them as a fraction. So 3.2 times 10 to the 4 divided by 6.4 times 10 to the power of minus 7. And then we can just treat the decimal bit and the power bit separately. 3.2 divided by 6.4 is 0.5. And 10 to the power of 4 divided by 10 to the power of 7. Well, we've got to subtract the numbers because we're dividing the powers. So we're going to get 10 to the power of 11 because we're doing 4. We're subtracting. And then what are we subtracting? We're subtracting a minus 7. So 4 minus minus 7 makes it 10 to the power of 11. So we've got an answer of 0.5 times 10 to the power of 11, but that's not in standard form. So we need to make the 0.5 10 times bigger, make it 5, but then make the other bit 10 times smaller, so make it just 10 to the power of 10, and the final answer is 5 times 10 to the power of 10, and that is in standard form.